11.4 areas of kites and related figures. First off, we have a new area formula for a kite. Area of a kite is equal to 1/2 multiplied by the length of diagonal 1 multiplied by the length of diagonal 2. Now, when we say diagonal 1 and diagonal 2, the diagonal runs from vertex all the way to the other vertex and vertex to the other vertex. So it's the length of the entire diagonal, not part of it. The length of the entire diagonal, not part of it. There's a great proof in your book for why this formula exists, right? It's a proof for the formula, but I'm going to tell you right now, it involves finding the area of this top triangle and these top two triangles and finding the area of these bottom two triangles. And when you do that, you get this formula: area of a kite equals 1/2 times diagonal 1 times diagonal 2. Now, here we have a rhombus right there. Now we need some proof to know it's a rhombus. So I went ahead and wrote in all the properties of a rhombus here. All four sides are congruent. So one tick mark, one tick mark, one tick mark, one tick mark. In a kite, the diagonals are perpendicular. Remember, a rhombus satisfies all the properties of a kite. So the same thing is true in a rhombus. The diagonals are perpendicular. Hopefully you can see that there with my square in the center where those diagonals meet. Not only that, in a rhombus, the vertex angles are bisected. So one tick mark, and the opposite side, one tick mark, one tick mark. And same thing for these two vertex angles here, two tick marks, and two tick marks, two tick marks. So in a rhombus, that is true in a rhombus, but not necessarily true in a kite. In a kite, we only have one pair of bisected vertex angles. But in a rhombus, we have two pair. And a square is also a rhombus. So all the properties of a rhombus also apply to a square, and also all the properties of a kite also apply to a square. So two tick marks, two tick marks, two tick marks, two tick marks. We know that's a rhombus. 90 degrees, 90 degrees, 90 degrees, 90 degrees. We know that's a square. You can see in a square, the diagonals are perpendicular. And we can use our area formula for a kite. Area of a kite is 1/2 times diagonal 1 times diagonal 2. That also applies to a square, and it applies to a rhombus as well. Now we are welcome to use our other formula for the area of a square, which is length times width, or side times side, and we can also use the same thing for the area of a parallelogram as it applies to both the square and the rhombus. That'd be base times height. Base times height, we learned that in 11.2, I believe. So with the kite formula in mind, try example 1 on your own. Pause the video now, try example 1 on your own. All right, so in example 1, we know dB is 24. We're going to find the area of kite ABCD. Now remember, the diagonals are perpendicular to each other. Okay, and one of the diagonals is going to be bisected. It happens to be dB in this situation. So dB is bisected. 12 and 12 is what we get. So how do we know which diagonal is bisected? It's the diagonal that connects the two sides that are non-congruent. So by that I mean D here is the intersection of the side length of 20 and the side length of 13. Those are not congruent sides. B is the same thing. It's the intersection of 20 and 13. So that is the non-congruent, where the two non-congruent sides meet at B. Compare that to C. C is the where the two congruent sides of 13 and 13 meet. And A, its opposite vertex, is where the two congruent sides 20 and 20 meet. So the way you know which diagonal is bisected is the diagonal that connects the two vertices where the non-congruent sides meet. So anyway, so DB, 12 and 12. We know the hypotenuse here is 20 and 20. That's a 3, 4, 5 right triangle. You could use the Pythagorean theorem, or you just memorize your 3, 4, 5 and hopefully recognize it when you see it, which is what we have here, which is 16. So if I can find CE, I'll have the length of that diagonal. Diagonal AC, well, 13, 12, and 5 is another Pythagorean triple. So 13, 12, 5, Pythagorean triple. 5 plus 16 is 21. So our two diagonals are 24. Remember I said it has to be the whole diagonal. 12 plus 12 is 24. And the whole diagonal here for AC, which is 16 plus 5, 21. Area of a kite is 1/2 diagonal 1 times diagonal 2. So area of this kite is 1/2 times 24 times 1, and we get 252 units squared. Try example 2 on your own. Find the area of a rhombus with a perimeter of 100 centimeters and one diagonal being 30 centimeters. Pause the video now. Try this one on your own. All right, so I have a crudely drawn rhombus here. So if the perimeter is 100, 100 divided by 4, each side is going to be 25. So we have 25 here. Now remember, in a rhombus, just like in a kite, rhombus is a kite, the diagonals are perpendicular. So we have these two diagonals, and they are perpendicular to each other. We know one diagonal is 30 centimeters. Now, in a rhombus, doesn't matter which one of these is 30 like it did in the kite, because a rhombus is a parallelogram. And in a parallelogram, the diagonals bisect each other, right? So with this diagonal here, I went ahead and said half of it is 15. So we have this right triangle, 15, 25. This is again a 3, 4, 5. 15, 25. The third side has to be 20. So from this, we can find the length of the diagonals. Be careful here. I think some of you might say 15 and 20 for the length of the diagonals, and that's not the case. Remember, 15 is half the diagonal. So the whole diagonal is going to be 15 times 2, which is 30. So that's where I get diagonal 1 is 30 here. Same thing for the other diagonal. 20 and 20. 20 plus 20 is 40. So 40 for the second diagonal. Area of a kite, which a rhombus is a kite, 1/2 times diagonal 1 times diagonal 2, and we get 600 for this rhombus. 600, that should be centimeters squared. I left off my units. I need to include those. There we go. Area of this rhombus is 600 centimeters squared. Go ahead and try example 3 on your own. Find the area of the rhombus shown here. Pause the video now. Find the area of that rhombus. Okay, I'm going to show you both ways to work this. If you didn't work it this first way, that is okay. In fact, understandable probably, given that it's not what we're learning today. It's something you've already learned. So this is a rhombus. We are given that one vertex angle is 60 degrees, so we know its adjacent vertex angle is 120. So I extend this right triangle here off the side in order to find the height, right? So if this is 120 degrees, the linear pair with it has to be 60 degrees. 60 plus 120 is 180. These are supplementary. We have the hypotenuse of this 30, 60, 90 right triangle. So to go from the hypotenuse to the short leg, 14 divided by 2, we get 7. 7 is our short leg. What we really want is that height, which is the long leg of this 30, 60, 90 right triangle. 7 times square root of 3 is our height. So here you see height is 7 root 3. The base is going to be 14, right? Remember, we don't include this extension of 7. We just use that to find the height. So 14 is our base. So area is base times height. 14 times 7 root 3, which is 98 square root of 3. If you did this the other method, you also got 98 square root of 3, and I will do that now. Okay, so we draw on the diagonals. Remember, the diagonals are perpendicular. So here you see they're perpendicular, and not only that, the diagonals bisect the vertex angles. So if this vertex angle down here is 60, half of that is 30. Well, if we have a triangle, one angle measure is 30, one of them is 90, the third angle has to be 60 degrees. So we have a 30, 60, 90 right triangle. Of this 30, 60, 90 right triangle, I have the hypotenuse, 14. It's opposite the 90-degree angle. So I want to find my short leg. Remember, if you don't have the short leg, get it. We go from the hypotenuse to the short leg, we divide by 2. So we get 7 for our short leg here. Now, to go from the short leg to the long leg, I'm finding the length of the diagonal. Short leg to long leg, we have to multiply by root 3. So we get 7 root 3. Now remember, these are diagonals that have been bisected, so 7 is half. The other half has to also be 7. 7 root 3 is half. The other half is 7 root 3. So diagonal 1 and diagonal 2 are going to be as follows. 7 times 2 is 14. So diagonal 1 is 14. Diagonal 2, 7 root 3 plus 7 root 3 is 14 root 3. That gives us the equation. Area is 1/2 times diagonal 1, 14 times diagonal 2, 14 square root of 3. This is going to be the same thing, which is 98 square root of 3. Both of them take roughly the same amount of work. I mean, neither of them is too complicated. So just choose whichever one you want to work with. All right, finally, try example 4 on your own. Find the area of a square with a diagonal of 7 inches. Pause the video now and try example 4. All right, this one may be the simplest one on the whole sheet. Remember, in a square, the diagonals are congruent. That is a property of a rectangle, and a square has all the properties of a rectangle. So in a square, the diagonals are congruent. So we have diagonal 1 is 7 inches, diagonal 2 is 7 inches, 1/2 times diagonal 1 times diagonal 2, and we get 24.5 inches squared. Thank you very much. Good luck on your assignment.